Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, Protect All of Your Applications, a Low-Code Approach, brought to you by Digital.ai. Before we get started, I do need to go through a couple housekeeping items with you, so just bear with me for a few moments. First, please remember that this is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We will be sending an email with instructions for how to access the webinar on demand, or you can visit us at devops.com/webinars, and it will be there for you as well. Throughout the presentation, we welcome your questions, so go ahead and use the Q&A tab on your console to submit those. We'll get to as many as we can at the end of the presentation. And make sure to stick around until the end, where we will do a drawing for 4 $25 Amazon gift cards. So stick around and see if you are a winner. Finally, with that, I'm pleased to introduce to you Mike Woodard. He's a product owner, security at Digital.ai. I'm going to turn my camera off and put myself on mute, and Mike, let you get right into it.
Okay, thank you, Sharon. Hello, everyone. Happy to be here today, and we're going to talk about protecting your applications with a low-code approach. First, a little bit about me. Sharon said I'm a product owner at Digital.ai in our security area. I especially focus on Apple and Android native code applications for mobile devices. We do other things too, but that is my particular area here. I've been in the computer industry for a long time, and I hate to admit it, but when I went to college, I was an outlier because I took my own computer with me. I know that is certainly not the case now, but I really enjoyed it, and I especially have enjoyed compilers and computer architecture and security. One of those people that assembly language was fun to me, integrated circuits. You know, I like to live down there, and so the things that we do in terms of protecting an application really resonated with me. And so I've been in security a while, did DoD stuff, did research stuff, have been doing commercial things with Arxan, which was acquired and combined with some other companies to make Digital.ai at the beginning of last year. So in terms of making a digital transformation, it's a big thing, but how to do it and what's going on. So as the digital age is upon us more, getting to the place where the value of our software and the value of our data competes or overtakes the value of the other parts of our company is here. And what are some of the problems we've got here? One is difficulty controlling the cost. There are lots of different, usually groups, and possibly with agendas, and certainly different software tools that they use, and procedures, and certifications, and things like that. And trying to get all of that to fit together, to work together, to be able to see what's going on can be expensive, and it's very complex because of all these different tools we try to have working together. It's a difficult thing to be able to kind of get a good view of what's happening. And the bigger your organization is, probably the more groups that you have that are using one-offs, and trying to get a handle on that is very difficult. If the teams are not communicating, if there's no common goal or vision for what should be happening, you can be far behind. And so what we want to do is figure out how can we get to the place where our groups are working together, where the software that we produce is having the impact that we want it to have, and we're really getting the outcomes that we want from doing our digital transformation. So at Digital.ai, we have this platform. Like I told you a minute ago, that these 5 companies came together so that we've got pieces of this puzzle here, from planning at the beginning, from orchestrating releases, doing protection, doing testing, looking at all of it through an artificial intelligence lens and trying to figure out what makes most sense, is what we're trying to do. And so, because one of the things, in terms of doing this orchestration, because of what we talked about just a minute ago, the various tools, them not necessarily talking together well, not having a good insight about what kind of changes can we make that may or may not kind of wreak havoc on our delivery and deployment. Being able to do testing early enough so that as we catch things, that we can make changes. And certainly, one of the focuses here is protecting the apps that we're putting out into the wild, so that we know that they're doing what they should be doing and not some other things. And so we're going to drill down into that part of this whole platform. So a long time ago, having a strong perimeter around your data center and having the right tools in place was good enough protection. But B2B came along and B2C, and so now that you have apps that need to talk to your servers, that are adding to the data that you've got in your data center and using it and making decisions based on that, has required that we punch holes through those firewalls, through all of that stuff, so that the apps that are outside of your control and outside your perimeter can make use of that data that you've got and can communicate with you. And so the threat landscape has really changed, and you know, as far ago as March 2015, 84% of the cyber attacks are happening at the application layer. Like there's little need to be inside the data center anymore, at least to launch your attack, because you've got these endpoints that are out in the wild, that are kind of unregulated, and I can do with them as a user or as an attacker kind of what I want, and use them to discover information about the APIs that you're using, about the endpoints that you're using, about what kind of data is going back and forth, about, you know, and which includes what does good data look like, maybe what does bad data look like, so that I can learn as much as possible about your infrastructure and what is back in your data center, so that I can launch an attack against it. And whether that, you know, I'm trying to steal IP, what tunnel into your data center and get that data, lots of things that I can do because I have an app on my mobile device that works and shows me what's the correct way to communicate with your back end. And for somebody who, for a company that doesn't want unsanctioned access, giving somebody a working example is a kind of a big first step toward teaching them what they need to do to get the access that they want. It really surprises me, and I don't know if anybody would have thought, you know, a decade or two ago that every kind of criminal that you can imagine in the physical world has got an analog in the virtual world. I mean, would anybody have thought that we have people who are kind of hijacking data and holding it kind of hostage for ransom? But these things are happening. And so being able to protect your apps is more and more important here. And so here, the whole idea is, because these apps are the endpoints that communicate with your servers that are out in the wild, we've got to extend the perimeter to encompass those apps on those devices so that users using them can do what they need to do, and so that we can get the value out of those apps. But the malicious users have a hard time, maybe not impossible, but have a hard time figuring out what those apps are doing, how they're communicating, and basically give them a much harder task of getting at what they ultimately want to do, and your data, your IP. And so the idea of taking an app that's going to be out in the wild and layering protection on it. I mean, the mantra of security is, defense in depth. You don't just put one mitigation on for a certain attack, but you figure out how to do it multiple ways, so that even if an attacker gets through one layer, there are other layers that need to be penetrated. And one of the things here at the bottom of the slide that is a little bit newer than the others is the whole idea of threat monitoring and analytics. It was very common, and it still is in too many places, for an enterprise to create an app that does something that they want to do. They build it and they put it out on the app store, and they hope that everything goes well. They may have looked at it and tried to figure out how to prevent against certain attacks, or how to use best practices to make that app as robust as possible. But once they release it into the wild, they can see that there are accesses to the data center going on, but really don't know how much scrutiny those apps are under, and whether anybody is learning things from those apps, whether those apps are being tampered or not. And so the idea of not just throwing something over the wall, but to maintain a monitoring and analytics posture to be able to see what's going on is also becoming more and more critical. So here's a question: is your app under attack? And we'll start out with a couple of simple answers. The first answer is, I have no idea if my app is under attack. This is the throw it over the wall scenario and see what happens. Okay? If you don't know whether your app is under attack, that's a big red flag. Okay? Because you don't know at that point what somebody is learning, what kind of attack they're preparing to mount, and what's going to be at risk. And so not knowing is really kind of unacceptable here. Another simple answer is, I assume my app is under attack. And while that's also a red flag, it's a little bit of a smaller red flag, because it's probably true that your app is under attack. And depending on what your enterprise is and what is the value, or maybe even the perceived value of a nefarious character doing something to your app, the higher that is, the more likely that somebody or a group of somebody are trying to understand your app, are trying to break it, are trying to do something that you don't want them to do. This chart shows just some statistics here about some apps that we have looked at in the first quarter with our threat insights. And this is not showing users, but this is showing uses of an app. And so almost all of the uses of the apps that have been looked at here were uncompromised, so that the users were using kind of stock devices, doing things in the normal way. So about 95% of those people and those uses, are kind of the intended audience and the intended use of these apps. But we have this 5.5% of compromised uses. And if we start at the bottom here, the unsafe environment, if you've got a rooted or a jailbroken device, that doesn't mean that the person using that is actively attacking your app, but it's almost a required first step to be able to get the app off the device, to be able to do anything else to the app. We've got to have that Android phone rooted or the iOS device jailbroken. We can move up from there, and things pretty quickly get way more threatening. So app instrumentation. If somebody is running your app in a debugger, that is almost assuredly not the use case that you're expecting. And while they may not have done anything yet, just the fact that they're running in a debugger means that they're kind of looking at what's going on in your app in a way that all of these normal users are not doing. And then there's this kind of very scary 4% at the top here, where the integrity of your app has been compromised. Okay, these are basically code changes to your app, so that somebody is not just looking at what your app is doing. Now they're changing things to see what happens if they change, this little bit of code or this piece of data. And so these certainly are active attacks on your app, which, as we talked about later, are kind of the first step toward getting at your backend servers, your backend data, understanding your IP, lifting your IP, repackaging your IP for their own purposes. Certainly not what you were planning for when you created this app that was going to bring you a certain amount of value. And so the question is, okay, what do I do about it? We'll go to the next slide here. One of the things that I want to look at, though, is take a little bit deeper dive about what is really required here. So it's very typical. You've got your software group. They're developing their app. Okay, they may or may not do anything to protect their app. They deploy the app, and here this is the kind of the throwing it over the wall scenario. So that the only time that you know something is happening to your app is if a pen tester finds something, which usually happens before you deploy. And so that gives you a chance to make course corrections and deploy at that place, or at public breaches. The worst of these public breaches, land your organization on the front page of the paper, okay? Other breaches can be not so public, but can also be bad. If all of a sudden you see activity on Reddit where attackers are talking about how they're probing your app, trying to get into it, and it's both kind of interesting and scary to watch some of those conversations, to see the amount of effort and ingenuity that can be mounted against your app. but it's the kind of thing that you don't want to see. And we have watched some of these go on, and sometimes the attackers think they're making progress and find out they're not, and we love to see them give up because a certain app is just too well protected for them to spend their time. It's also funny that attackers have an ROI in mind, and that it's they're putting in a certain amount of time to get their desired outcome. And if it takes too long, if it's too hard, if it's too frustrating, there are lots of other apps that they can go attack. And so they may put down one that's well protected and turn toward an app that is much less better protected. So when something happens, okay, teams, that see something on Reddit, okay, they can respond, but they may or may not know exactly what's going on. They're just seeing a discussion about what's happening. There's also little confidence in terms of the people that are looking to see if the app is working, to have confidence that the protection level is kind of appropriate to the value of the app. Premium app protection is generally more time consuming. If you think about an app that has a high value, it makes sense that you're going to kind of invest in the protection of that to make sure that that is not broken. You may have lots of other apps that you think of as, kind of having lesser value, and maybe they don't need as much protection. But knowing exactly what is the right amount for a given app is sometimes tricky to determine, and without having any feedback, then it's hard to know whether you have kind of shot close to the target or not. And so the idea of app optimizing your protection is difficult. When you protect an app, you're adding code, and so your app is always getting bigger, and it's always taking a little bit longer to run than before, because you're running all the normal functionality of your app, plus you're also running the protection mechanisms that are there. And again, if you don't know what's going on once you release your app, then you don't know, did I make the right trade-off in terms of optimizing and balancing performance and protection. And I just alluded to this a moment ago, but if you look at your apps that your enterprise has, okay, there are probably few franchise apps. These are the ones that you know are your money makers or are critical to you, that you don't have very many of these, and so you can go to the effort of protecting them well, because you don't want to have those compromised because the consequences are too great. But there are other apps. There are these, what we're calling important apps here, and there are more of those. And then there are other apps that maybe are not very important at all. These could be apps that are only used by people inside your enterprise. They could be apps that don't really communicate with your data center at all, don't use any data. And the amount of protection that you use on these apps really should be commensurate with the importance of these apps to your business. And for a long time, my company, Arxan, has worked on protecting those franchise apps, those top-of-the-line apps that really need top-tier protection. But the truth is, there are kind of relatively few of those apps, and there are more low-code and no-code techniques for producing apps. And so there are a lot more of these kind of important apps and other apps. But again, just because it is a low-code app or a no-code app, just because it's being created by somebody who is kind of not trained to be a developer, doesn't mean that that app has no value. And so extending protection of that with something like our essential app protection gives you kind of that first line of defense. And we'll look a little bit more at what some of those techniques are going to be, but to give you some protection and to give you the feedback that you need so that you know, am I protecting enough? Do I need more protection? Are attacks going on? And for kind of basic essential app protection or premium app protection, this is how things usually break down. So for essential app protection, these apps that we have lots of, we want to protect them kind of as simply as possible. We don't want to have too much configuration because that takes too much time and investment to figure that out. So if we've got an app that has kind of a lesser value to us as an enterprise, we might go toward the essential app protection end of the spectrum. If we've got a premier app, then we probably want the premier app protection. But in both cases, we want to know once that app ships, kind of what's going on with it, how is it being used. Also, another critical piece this day is that protection has got to be kind of seamlessly integrated into your pipeline, your software delivery pipeline. And so it's got to be able to be run from command line, by Jenkins, by whatever you're using to produce your app. And then other features that are needed in varying amounts depending on the value of the app are like unsafe environment detection. We talked about that before. You know, is it being run on a rooted device? Is it being run in a debugger? How much code obfuscation is there to protect against static analysis? Can we tell when somebody is actually tampering and changing, our binary? Do we have crypto keys that exist on the app that an attacker can get and then use in for example, a media player app of their own? And then, what kind of support you get? And again, for those lower value apps, you can generally get away with a lower level of protection. And so something like essential app protection gives you the kind of the entry level version of lots of those things. And because you've got the threat reporting and insights, you can always see, okay, I see that my app that I thought was kind of low value is being attacked more vigorously than I expected. And that may be because it's communicating with the same servers, it's using the same APIs that your franchise app is using. And at that point, maybe say, okay, this is more valuable because I'm giving the attacker entry into into my protected environment through kind of a back door or through a less protected mechanism. And so maybe I want to protect that a little bit more because I see that it has a greater value to me than I thought because of what it allows an attacker to do. And I've talked about essential app protection a little bit, but let me go into this just a little bit more. And again, this is for those kind of important apps, for those lesser important apps, but something that we do want to pay attention to still. So it could be that these are low-code apps or no-code apps, but this is a low-code approach to be able to protect an app. And so in the middle here, you've got your iOS or Android app. And let's just consider Android for a second. So you've got an APK here. And you could ship this. But if you ship it, now you don't have the analytics and insights that you would have, and you don't have the protection mechanisms built into that app. So what you could do with Essential App Protection would be to run a single command as part of your software delivery pipeline, and connect it to a protection library, so that this app now has got minimal changes, versus like a premium protection where you may have to be integrated into the build system, where the changes have to be made at the bit code level, for example. Here, because we just have the final APK, we're going to make some minimal changes to that, just enough that we can tie this protection library to it as securely as we can. And that library has the functionality that has the environmental detection guards, that does threat insights, that has the runtime self-protection, and things like class encryption, so that we can thwart the attackers at least somewhat in terms of figuring out what your app is doing, or trying to pull it apart so that they could take your app and do more to it in terms of attacking it. So by adding the feedback of threat insights, now we can get that visibility into what's happening in the app, so we can really close the loop from the picture that we had before. So after we develop, we protect, we deploy, now we can look at the data that I showed you before. I showed a summary of that data of what's happening to your app, and I can drill down and find out. It may just be interesting to me about the environment that the app is running in. It's more interesting and troubling when I see somebody is changing my code. But at that point, I can see it happening kind of in real time. If you've got the monitoring and reporting, then you could be notified with an email message that an attack is going on. Depending on what data you choose to monitor, you can find out who's the user who's doing this, and let me turn off that user's access. It could be that if you've got a financial institution app, it may be that that I'm going to make the user go through an extra step of authentication. I'm going to make them call or come into a branch or something like that to make sure that somebody is not able to, with stolen credentials and somebody in a tampered app, to do something that you don't want to allow. You can do things kind of automatically. You can do things by changing what happens on the back end in an effort to stop fraud, protect your IP, any PII, and your brand. And as you watch what's happening, you can continually make that decision. Am I protecting my app enough? Do I need to do something more? And because you've got data of real attacks, it can help you make that decision better. Here's just a slide that shows what you can do, so that you can look at these events with threat insights, that you can kind of get up to date an assessment of your security. Ideally, this data can flow into your SOC, so that it's just part of the other data that you've got, so that you can understand kind of what your footing is in real time. And again, you can have different responses to different kinds of threats. So starting at the bottom here, here's the unsafe environment again. So root or jailbreak detection, okay? You can decide, is that a big enough deal? You want me to stop, what the app is doing, or you want to let the user continue with a rooted device, but I'm going to pay a little bit more attention to something. As we come up the stack here, if you detect you're in a debugger, you want to be maybe a little bit more stringent in what you do. And certainly if you see that the signature of the app is different than what it was when you shipped it, in a checksum, for example, has been triggered, that an attacker has modified your app, is re-signing it, is trying to use it in a way that you didn't intend. And so the value that you get here from kind of essential app protection is the ability to add layers of defense so that the app can actually detect some things on its own, and that it can pass what's happening in the app's memory space up to an analytics server so that your back end can see and respond to those things, and so that you can get kind of the reports that you need. Because it is a low-code approach, that the binding to your app can be done with kind of a single script without you needing to make decisions, and can be put into your CI/CD pipeline very simply. And that's all we've got. So yeah, I would love to answer whatever questions that you have for me now.
Awesome. All right. Well, let's get right to it then. First of all, what are some examples of franchise apps?
Okay, so yeah, when I say a franchise app, I'm thinking of an app. Well, it can be an app that is a big moneymaker for you. It can be an app that has millions of seats in terms of people that are using it. It's a kind of app that if an attacker is able to get in and do something to that app, that it really has a big impact on your revenue stream, or could land you on the front page of the Wall Street Journal. So think about all the things that you do in terms of anything that you do financially online, anything that you might do, if you've got an app that is connected to your insulin pump or some other kind of medical device or something like that, anything where, if you think about what would happen if an attacker kind of got free reign with this app, how big a deal would it be for me as the enterprise? And kind of the bigger deal it is, then the higher on that spectrum of franchise app, it is. So I don't want to name any names of specific things, but we'll leave it at that.
Gotcha. That totally makes sense. All right. What kind of tools do you recommend to implement essential app protection? And I assume by essential app, we're talking about those kind of franchise apps that must not be named. Threat insights, runtime self-protection, class encryption, those kind of things. What other kind of tools do you recommend?
So, certainly our company is not the only one in this space. And again, that as you look at your app and as you do kind of a careful assessment of the value, to figure out, do I need to, for example, stop this app if I see certain of these things happening, or do I just want to know about it? And so there are different things that you can do. There are some very basic kind of freeware protection things that give you a little bit of protection. maybe it goes in and it renames all the classes in your Java app, so that if an attacker starts looking at it, and they're looking for a confirmed password, that they don't see it show up like that. With no protection, then you just inspect those classes and you can see those names. And because software engineering has been taught in our universities for 40 years, everybody knows that to make your code readable, modifiable, updatable, you want to use good names. You want to have everything kind of close together that deals with the same object, and all of those things that make it easier for you to maintain your code also make it easier for the attacker. So there are some things that you can do just by renaming things, for example, that raise the bar a little bit. Beyond that, do you need to know whether you're in an unsafe environment? Do you need to know if a debugger is running? Do you need to know if your code is being modified? Do you need to know if somebody is trying to get your crypto keys out of your app? And there are various kind of levels of products that you can use, as you kind of go up into the scary scenarios of what an attacker might be doing.
Gotcha. All right. Let's see what else we've got here. Following on there from the essential app protection question, what are the performance impacts of that essential app protection?
So again, if you go back and think about the spectrum of apps, from kind of the low value apps, and nobody likes to think that they've got a low value app, but from those low value apps up to the very high value apps, the amount of protection is probably going to be variable, that you need less protection in the low value, more protection in the high value. And because you'll have more protection mechanisms in the high value, you probably have a little bit more of a performance impact at that end. So if you're, at that end, if you're doing checksums often, if you're, checking for debuggers or checking for other kinds of instrumentation, all of those checks that you do are taking up some of the cycles that otherwise would go to your app. Now, sometimes they can be on another thread, and so it doesn't matter very much. But still, the more you do in terms of your detection and your protection mechanisms, the more of an impact it's likely to have. Now, all of that is tunable, and people spend a lot of time, or they spend some effort tuning apps to try to do that. But at the lower end, down at the kind of the essential app protection, at the lower value app end, you're probably going to see way less performance impact. You might not even notice it because there are fewer checks not being done as often. The checks themselves are not as invasive is not the right word, but are not as time consuming. And so you probably won't even be able to tell unless you open your app in a decompiler or a disassembler to know that there's protection there.
Okay, makes sense. So circling back, well, actually, we'll come back to that one. I want to grab, this is another question about essential and premium protection. What is the difference between essential and premium protection in terms of the difficulty in implementing and maintaining it?
So the easy part of the answer is, for essential protection, the difficulty of implementing it and maintaining it is very little. You've got your build pipeline, and now you bring in your essential app protection tool. You insert a command that says do the protection at this stage. So I produce my APK or whatever. Do the protection at that point. And instead of sending that APK directly to, a Google Play Store, you do the protection and then it goes off. And once you've put that in your pipeline, every time you build, you can just build a protected application, which is also very good. I didn't talk about that here, but the whole idea of doing your protection early, kind of doing a shift left on your protection, and then looking at your testing, is really beneficial so that you don't get to the end of your development, try to do some protection and find, okay, I've got a performance issue I've got to deal with.
Right.
So the simplicity of the essential app protection is very simple, very easy to do. And at that point, I think of it the way that I think about my house and my truck. Okay, I live in the country, and very often, if I'm going to go out, I might go out the front door, pull it closed, but not lock it. I mean, I do have a German Shepherd, so she's a little bit of a deterrent, but I don't necessarily lock my front door. Certainly if I'm going to walk around the neighborhood, maybe if I go to the store. But let's say I drive to the store. I've got a truck that I drive, not a very new, expensive truck, but I've got a fob in my hand that all I have to do is press a button, it locks the doors, and it sets the alarm. Now, am I concerned really about somebody, am I more concerned about my truck than my house? No, but it's so easy to protect my truck by pressing that button that I just do it automatically. And that's kind of my idea for essential app protection. It's like, let's make it so simple that there's no reason not to do it. And we get that first level of protection, and now we can start to see what's happening and decide, is it enough protection or are I doing something else? Up at the other end for the kind of the premium apps, there's usually more, there's always more configuration. And so figuring out, I've got this whole slate of protection mechanisms. Which ones do I want to use? When do I want them to be kind of invoked and run? What should happen if tampering is detected? So there are a lot more decisions for me to make, and so there's usually kind of a steeper upfront cost. But now, once I've identified that protection, then there should be minimal kind of maintenance, because again, it's part of my build now, and as I build my app, I protect it with the more extensive mechanisms. And really, I only need to come back and revisit those if I'm kind of making major changes to my code base, or if I detect that something's going on and I want to, in terms of an attack, and I want to upgrade my protection.
Okay. Yeah, that totally makes sense. All right. So let's see. And this goes back to something you mentioned a few minutes ago. Everyone believes that their app is critical. So do you have any suggestions for how to be more objective when you're identifying which apps are more or less critical to the organization?
Okay, so there are some, there are kind of some simple things, simple questions that you can ask to try to get at this objectively. And then there's some things that maybe are a little bit more subjective. First thing is, if your app is controlling the flow of money, so if it's an app, that's the front end to, to a store, if it's a brokerage house app, if it's a banking app, if it's something like that, that kind of automatically propels you into the, I should pay attention here.
Yeah.
And we have, no industry has kind of a stellar reputation, industry segment in terms of doing the protection. In the financial area, they're pretty on their guard, though. They understand that. I mean, they've been dealing with fraud for a long time. This is a new way to do, perform fraud. And so if you're exchanging money, that's something. Another one that's pretty easy is if somebody's health, is at risk. So the insulin pump, the pacemaker, those kinds of things. If you've got an app that is controlling that, certainly, maybe even observing it, because observing it, it's able to query the device for, flow rates or things like that. Those are things.
Okay.
Then I think the one that your finance department would understand the most is, okay, what would happen if this app totally went away today? Are we going to be in business tomorrow? So if your revenue stream, if your livelihood is dependent on this app working, then that's another thing that kind of propels it to the top. And it's like, okay, you really want to pay attention to this. If it's, at the other end, it's like, well, if this app went away, it would be an annoyance, but we could just open a web browser on our laptop and do the same thing, then maybe that's one, that's kind of toward the bottom of the spectrum. And there are probably some other things like that, that are germane to different industries where you can kind of look at it, from your industry perspective. Yeah, what if my competitors had this? Is that a big deal or something like that?
Right.
But those are kind of the big things that come to mind right away.
Okay. Fantastic. Well, I think that is all the questions we have time for today. If you submitted a question and we did not get to it, rest assured, we're going to take all of those questions and forward them on to Mike, and he will be able to get back to you offline. So with that, I just want to remind the audience that this session has been recorded. So if you missed any or all of it, you'll be able to go back and watch it again. We will send out an email with instructions for how to access the webinar on demand, or you can visit us at devops.com/webinars, and it will be there for you. Now it is time for us to choose our winners for the Amazon gift cards. All right. Our first winner today is Jane C. Congratulations, Jane. Next, our next winner is Elizabeth E. Congratulations, Elizabeth. Our third winner is Bob B. Congratulations, Bob. And finally, David A. Congratulations to all our Amazon winners. If you didn't win this time, you'll have to come back and see us again for another chance. Also, just a note for our winners, we'll be sending an email to you with instructions for how to claim your gift card. If you don't see that in your inbox within a short time frame, make sure and check your spam folder, because sometimes those do get stuck. Thank you to our audience also for spending an hour of your time with us. And thank you so much to Mike and to Digital.ai for this amazing presentation. That'll about do it for me. I hope to see you again soon at another DevOps.com webinar. I'm Sharon Florentine, signing off.
Thank you, Sharon.